All right, so 4.7 is going to be talking about the fundamental theorem of algebra. The fundamental theorem of algebra is used when solving equations. It tells us that the number of solutions is the same as the highest degree. And we've actually talked about this a couple times in class, right? We said if there was an x to the fourth power polynomial, we should get 4 solutions. So, note, in order to account for all the solutions, you must consider multiplicities and imaginary zeros in some problems. Let's take a look at this first one. It says if the 0 square root 2 comes from a quadratic function, remember our quadratic is x squared, what must the other 0 be? Well, if we have a positive square root of 2, we also have to have a negative square root of 2, no matter what. So what can we conclude about irrational zeros? They always come in pairs. The least degree of this function is 2 because we have one solution here, another solution here. So the least degree would be 2. And then it says find the quadratic equation for number 1 in standard form. Well, if you think the two zeros are x equals square root 2 and x equals negative square root 2, that would lead us to the factors being x minus the square root of 2 and then x plus the square root of 2 if we would set both of those things equal to 0. So then if we just take those two factors and we multiply them together, you actually can get out the quadratic equation for this. So we multiply, you get x squared minus the square root of 2x, and then plus the square root of 2x, and then square root 2 times square root 2 is going to give us negative square root of 4. If we combine these things together, these will cancel, and we get x squared minus 2 is our quadratic equation that has those two zeros. Which that makes sense, right? If I told you to solve this equation for x, you would set it equal to 0. X squared minus 2 equals 0. Add 2 to the other side. X squared equals 2. And then square root both sides to get x is equal to plus or minus the square root of 2. Well, what if the zeros are 1, negative 2, and 3i, and those come from a quadratic function? Are we missing a 0? Okay, so I think this is supposed to say, it should say polynomial function, not quadratic function. I'm not sure. I should probably change that. Sorry. If the zeros are 1, negative 2, and 3i all come from what is the missing 0? Well, 1 and negative 2 don't necessarily need to have a pair, but anytime there's an imaginary number, it should also have its negative version as well. So what can we conclude about imaginary zeros? They also come in pairs. So these always come in pairs. So the least degree of this function would be 1, 2, 3, 4. So fourth degree because we can see at least 4 zeros. And then it says right, again, should say polynomial equation. Sorry for the typo there. For number 5 in standard form. So the x's are 1, x equals negative 2, x equals 3i, and x equals negative 3i. Write all the factors, so that's x minus 1, x plus 2, x minus 3i, and x plus 3i. And now it's just a lot of multiplying together. So I'm going to go x minus 1 times x plus 2 times x minus 3i, x plus 3i. So x times x gives us x squared. Negative 1 and x is negative x plus 2x minus 2. That would be those two on the left multiplied together. I'm going to multiply the two on the right together now. So that's x squared minus 3ix plus 3ix. And then 3 times 3 is negative 9. I times I is I squared. So this I squared, remember, is really square root of negative 1 squared. So that becomes just negative 1. So negative 1 times 9 becomes positive 9. And then we have x squared plus 9 because the negative 3ix and positive 3ix will cancel. And then that's getting multiplied by x squared plus x minus 2. And that comes from negative x plus 2x makes a positive x. And then we need to multiply one more time together. So x squared times x squared is x to the 4th plus 9x squared. And then plus x cubed plus 9x minus 2x squared minus 18. Finally, we can finish this question with just a little bit of simplifying. So that's x to the 4th plus x cubed, 9x squared, and negative 2x squared makes positive 7x squared. And then that minus 18 at the end. So x to the 4th power, right? We have a x to the 4th power, which accounts for all 4 of our zeros. And that's kind of the new thing we're looking at today. Okay, it's just identifying those missing zeros. So problems 7 and 8, it says find 2 additional roots of a polynomial function, p of x. All right. In this case, when you have 2 terms here, you need to think back to where does this come from? Well, the solution, if you get something where it's 3 plus 2i, actually comes from the quadratic formula. So think back to the quadratic formula. It's negative b plus or minus the square root of, and then that's all divided by 2 times a, right? So think about where does the plus or minus exist. It exists between the square root and between the constant term. So here's our constant term. The square root exists in the I, so then between that is a plus sign. So that means the other one has to be 3 minus 2i. So the middle sign is the only one that's changing. In the other case, square root 3 is just going to become negative square root 3. And then there's our other 2 possible solutions. If that's confusing to you, why we only change the middle sign, please ask when we're back at school. When you're back at school, and I would love to try to explain that a little bit better. Number 8 follows the same pattern. Right here we have negative 4i. So we should get a positive 4i is one of the solutions. Again, here we think back to the quadratic formula, negative b plus or minus the square root of, right? So here's our negative b, here's our square root of, so it's giving us a plus, so that means we're missing the 1 minus the square root of 5. And then there would be our 2 more possible, or 2 more solutions for that polynomial function. Problems 9 through 10, write a polynomial function that has the given zeros, okay? We need to make sure we write all of them. So I'm giving you 7 and square root of 5. One more is the negative square root of 5. So these are the 3 that we would use. So we'd have x minus 7, x minus the square root of 5, and then x plus the square root of 5. And again, that comes back from changing the x equals into their factors. So we can multiply here. I'm going to multiply the right 2 because between these 2, the middle term will always cancel. Notice plus and minus, and then the same values on the end. So then we have x squared minus square root 5x plus square root 5x minus the square root of 25. So these cancel, and you get x squared minus 5 multiplied by x minus 7. Multiply through again, you get x cubed minus 7x squared minus 5x plus 35. And there's our solution. Taking a look at this next one, we're given that 1, remember, our imaginaries always come in pairs, so negative 2i as well. So we have x minus 2i, x plus 2i, and then x minus 1. Again, out of these left 2, because it's a plus and a minus, the middle term is going to go away. So multiply those first always. X squared minus 2ix plus 2ix minus, and then that's 4i squared. These 2 go away. I squared is really negative 1. So negative 4 times negative 1 is positive 4. So that's x squared plus 4 times x minus 1. And that gives us x cubed minus x squared plus 4x minus 4. And there's our solution. Okay? Notice that when you do this multiplying through the first time, x squared plus 4 should give you back your two imaginary solutions. Same over here. This x squared minus 5 gave us back, if we solved for x, plus or minus the square root of 5. So that's a good way to just do a quick check to make sure you're multiplying through correctly. So let's tie everything together that we've done for the entire unit now. Consider this function 2x to the fourth minus 7x cubed minus 8x squared plus 14x plus 8. Right? We got 5 terms. We don't know any type of factoring for something with 5 terms. So we can't factor to figure out how many zeros this thing has. So we're going to have to do something differently. We know by the fundamental rule of algebra, or the fundamental theorem of algebra today, a fourth power tells us that we have 4 zeros. Okay? Real, imaginary, rational, irrational, doesn't matter. There are 4 zeros because it's a fourth power equation. The possible rational zeros for this function, okay, this is what we did 4.6, so the other day. Rational zeros, p's come from the back, so 8. So my p's come from 8. So we have 1 and 8, 2 and 4. Our q's come from the front, which is just 1 and 2. So then our p over q list always starts with a plus or minus, and then we have all of these terms over 1. So that's 1, 2, 4, and 8. And then we need to put all of those terms over 2. So 1/2. And then technically it's 2 over 2, which is just 1 again. It's 4 over 2, which is just 2 again. And then 8 over 2, which is just 4 again. So we don't need to rewrite any of those. We're just good right there. 1, 2, 3, 4, 5 times 2, because it can be positive or negative. So there's 10 possible rational zeros for this function. It says, without a calculator, find the zeros using synthetic division and factoring techniques. You'd be wise to work with your group and each tests different possibilities. Clearly, because you're watching this video, we don't have groups. So I'm just going to give you the first one here. I know that positive 4 works. Okay, so we're going to use synthetic division with positive 4. You have 2, negative 7, negative 8, 14, and 8. All right. It would be awesome to practice going through and trying synthetic division with a couple numbers to see if you can figure it out on your own. But by all means, on the test, you would get a graphing calculator to at least find the first zero and then be expected to show all work after that. So you find 4, you drop down the 2, you get 8, negative 7 plus 8 is positive 1. So positive 4 here, negative 8 and 4. It's going to make a negative 4, which makes negative 16. Which then makes negative 2, which makes negative 8 and gives us 0. All right, so then our divided polynomial that we have, remainder is first, remainder, constant x squared, x cubed. So we have 2x cubed plus x squared minus 4x minus 2. From here, you can look at this and you can say, can we factor this? And I think actually we could factor this by grouping. But say you didn't see that, what you would need to do is you would just go back through and you would start trying some more zeros. Or if you plugged it into your calculator, you would have saw that another 0 exists in this thing. So the other 0 that exists is negative 1/2. And then you could use synthetic division with that. So we do 2, 1, negative 4, negative 2. So that gives us 2, and then negative 1, which would give us 0. Negative 1/2 and 0 is 0, which gives us negative 4. Negative 1/2 and negative 4 is positive 2. Add those and you get 0. So then you get 2x squared minus 4. So this is 2x squared minus 4. And then we would be able to solve for our two equations once again. Now we would be able to find all of the zeros, right? So the two zeros that we have already are 4 and negative 1/2, which is awesome. And then the other zeros are going to come from solving this. So 2x squared minus 4 is equal to 0. Add 4, so 2x squared is equal to 4. Divide both sides by 2, and you get x squared is equal to 2. Square root, and we get x is equal to plus or minus the square root of 2. So then to summarize our 4 answers, we have x equals 4 plus or minus the square root of 2 and negative 1/2. And we need to write all of those. Okay? And that makes sense, right? We were supposed to get 4 zeros. We got our 4 zeros. So it's all coming together now. Using our knowledge of end behavior, zeros, y-intercepts, sketch the graph of this function. Okay? So we know that we have positive 4 and negative 1/2. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. So positive 4 is an x-intercept. Negative 1/2 is an x-intercept. Positive and negative square root 2. So how would you graph that? Yes, you could plug in square root 2 into your calculator. You can also remember square root 1 is equal to 1. It takes square root 4 to get to 2. So that means square root 2 is somewhere in between 1 and 2, probably a little bit closer to 1. So that means it's going to be negative a little bit bigger than 1, and then positive a little bit bigger than 1. So there's some zeros right there. It's probably even more. Here and here. Okay. And then lastly, we definitely need to graph the y-intercept as well. Remember, y-intercept, you just plug 0 into the equation. That's always how you do it. So 2, 0 to the 4th, minus 7, 0 cubed, minus 8, 0 squared, plus 14 times 0 plus 8. So really, all of these go away, and you're just left with positive 8. So 1, 2, 3, 4, 5, 6, 7, 8 puts us right here. And then end behavior, we know that it's a even degree function, so that tells us that it's either going to open up and up or down and down, and it's positive. So positive even tells us that we're up and up. So there's no bouncing or anything here. None of our zeros have a multiplicity of 2, so we're physically just crossing at every single one of these. So we go down, back up, back down, and then back up. And then right there is our function. Okay, so check that out. I gave you a polynomial function, 4th degree, higher than anything that you've ever had to graph in your life before, right? We found every zero. We graphed all of the zeros. We found the y-intercept, and we graphed it. So this is how you can physically graph any type of polynomial equation that I give you ever. All right? So in my opinion, it's kind of cool, right? I could give you like x to the 5th minus 7x to the 4th plus 8 plus 2x, right? And you could figure out how to graph that because you know all of these different skills. In my opinion, pretty cool thing. You probably don't feel the same way. But either way, if you have questions, guys, I know I kind of went through these kind of fast. Please, please, please message me on Canvas. I would love to talk. Anticipate a test coming up soon. But yeah, have a great day.